All right, and continuing on with the 2020-12B, problem number 6. For all integers n greater than or equal to 9, the value of this is always which of the following? Don't worry about the answers, worry about this. Just start factoring stuff. You should know that n plus 2 factorial is n plus 2 times n plus 1 factorial. And since that's the case, we factor it out to get n plus 1 factorial times n plus 2 minus 1, which is n plus 1, over n factorial. You can probably see the answer from here, but n plus 1 factorial also reduces to n plus 1 times n factorial over n factorial, and there was another n plus 1 here. Those cancel. N plus 1 times n plus 1 will always be a perfect square. Right, and this is the 2020-12B problem number 7. This was the first question that I felt where it really started to pick up and how much you have to think about it. I'm going to solve it in 2 different ways. I did both during the test because I wanted to confirm that my answer was correct. 2 non-horizontal, non-vertical lines in the xy coordinate plane intersect to form a 45-degree angle. One line has slope equal to 6 times the slope of the other line. What is the greatest possible value of the products of the slopes of the 2 lines? It doesn't say that it goes through the origin, but if you want to assume that it does, it won't hurt anything. So we can just go through here and we'll put a point here and call it 1, and the point here m, so it's going up m over 1. Now, if I come down and do another line that looks like it's got a slope of 6m, it will hit the y-axis farther down. In fact, from this point, you're going to go up 6m and over the same 1, so this will be located at negative 5m. Furthermore, if we drop a height right here, we get a right triangle, making this distance the square root of 1 plus m squared, 1 being here, m being here. We can do the same thing with this one coming over to this side. This is 1 and this is 6m, so this will be the square root of 1 plus 36m squared. Okay, and the angle that they create is 45 degrees. This is y equals 6mx plus negative 5m, or just minus 5m. Okay, what we can do now is law of cosines. We know that this distance from here to the origin is a distance of 5m. So the angle, the side opposite is 5m. We will get 25m squared equals. You do the adjacent legs. Again, if you don't remember, it's c squared equals a squared plus b squared. This looks just like Pythagorean, is how I remember how it starts. Minus 2ab cosine of whatever angle is opposite this side. So that's what we're using right now. 25m squared is equal to 1 plus m squared plus 1 plus 36m squared, because they both get squared, and then minus 2 times the square root of 1 plus m squared times the square root of 1 plus 36m squared times the cos of 45. Which is why I elected to use this the first time I approached this problem, because cos of 45 is well known as root 2 over 2. Now these 2's will cancel. I'm going to take this negative expression and move it to this side and move the 25m squared over here. I've got 36 and 1 is 37 minus 25 is 12m squared plus 2. This negative is going to move all of this over here. So I get 2 times the product of the square roots. I do this a lot in competition. You don't have to write everything. You're not showing your work to everyone. You're showing it to yourself. And if you know this represents that, there's not really a need to write it. You're now going to square both sides. Actually, it was root 2. So you're going to square both sides. You're going to get 2 times 1 plus m squared times 1 plus 36m squared equals, squaring over here is 144m to the 4th, plus this times 2 is 48m squared plus 4. Okay, now we're going to divide by 2 because we can. We're going to simultaneously distribute here. 1 plus 36 and 1 is 37m squared plus 36m to the fourth. Dividing by 2 over to the other side gives 72m to the fourth plus 24m squared plus 2. This is a bigger m to the fourth. We'll move to the right and get 0 equals 36m to the fourth. Subtracting 37 gives minus 13m squared. Subtracting 1 gives plus 1. Now we try to find a factorization. We know this has 9 and 4, and that's 13. We've got it. It's 9m squared minus 1 times 4m squared minus 1. Solving this equal to 0 is going to give m squared equals 1/9 or m squared equals 1/4. Okay, now what we're looking for is the greatest possible value of the product of the slopes. What is that? It's 6m squared. Okay, because m times 6m is 6m squared. 1/4 is bigger than 1/9. So we're going to take the 1/4. 6 times 1/4 is 6 over 4, 3 over 2. That's answer choice C. Let's do it a second way. We're going to run it back and try it a different way now. So the different way that you can do it is you will not use those side lengths this time. We know that this is 45 degrees, of course, and we know that this we can call theta. Now, we know that tangent of theta is the slope of this line, and that is m over 1. So we can write that down as a fact. Tangent of theta equals m. Furthermore, we know that this angle up here, the whole thing, if I do the whole thing, is 90 minus theta. And since this part is 45, I take that away, and this is 45 minus theta. That means this angle right here has to be 45 plus theta. Now, we also know this is still m over here, and we know the slope of this line is 6m. So m over whatever this is has to equal 6m. m over something has to equal 6m. That something must be 1/6. So we're going to write 1/6 right here. And now we're going to operate. We have the tangent of 45 plus theta using this angle right here. So tangent of 45 plus theta is going to equal the opposite m over the 1/6, which is 6m. Okay, now all we have to do is recall our formula for the tangent sum of two angles. It is tangent of a plus b equals tan A plus tan B. It has the same sign on top that it has here, and then it has the opposite sign on the bottom, tan A, tan B. Okay, then after that, we're just going to plug in. Tangent of 45 is 1, so tangent of A and tangent of A, we're going to make it 1 instead of what it says. And tangent of B is tangent of theta, which is m. So this is equal to 1 plus m over 1 minus m. And we know that that is equal to, again, 6m. So now we cross multiply. 1 plus m equals 6m minus 6m squared. Let's move it all to the left. We will get 6m squared. Subtracting 6m gives minus 5m. And then we still have plus 1 equals 0. This will factor to 3m minus 1 and 2m minus 1, giving m equals 1/3 or 1/2. Once again, we return to our expression 6m squared. 1/2 squared is 1/4. Just as we got the other way, we definitely know we're right. You don't necessarily have to do a problem two different ways on the test, especially your first run through, but hey, in this case, it helps confirm. Okay, and now for the 2020 10B problem number 9, which was also the 12B problem 8. How many ordered pairs of integers x, y satisfy the equation x to the 2020 plus y squared equals 2y? Kind of a big exponent. You know, how do we begin this kind of thing? Well, just start manipulating it in some way. Could I move stuff to one side or the other? Yeah. Now, what I want to move these things over here, or one of these things over here, I don't really want a negative y squared. I don't know why I would want a negative x to the 2020, but maybe I can move the 2y over here and take advantage of the 0. Okay, then I can already see what's going to happen now, because this looks like something, if you've done Algebra 1, you should recognize as the potential of it. And the potential of it is you can complete the square. So you complete the square, x to the 2020 plus, you're going to cut the negative 2 in half. That's y minus 1 squared. You're going to square the negative 1 and add it to both sides. You can't just add it to one side because you have an equal sign. All right, then this is equal to 1. From here, it's simply a matter of thinking. I've got, this is obviously a perfect square, whatever this is, but so's this. So really, this is a square plus a square equals 1, and since x and y need to be integers, we know that these expressions are integers as well. So is y minus 1. That means my possibilities for x to the 2020 are 0, and y minus 1 is 1. Or x to the 2020 is 1 and y minus 1 is 0. Now be careful, we're not saying x is 0, y is 1. Well, in this case, x is 0. But we're not saying that y is 1 exactly. We're saying the expression y minus 1 squared has to come out to be 1. Okay, so with the 0, 1 version, you're going to get x is 0, but there's more than one way for y to be 1. Y could be 0, or y minus 1 squared to be 1. Y could be 0. That gives you negative 1 squared, which is 1. But it also gives you 2. If y is 2, we'll give you 2 minus 1 squared is also 1. So both of these work. Now, if x to the 2020 is 1, be careful, there's also the negative 1. So you could use 1 and y 0, or negative 1 and y 0. You get 4, you're sure they all work. You can plug them back in if you're not sure, but they do all work. It's definitely not going to be infinitely many. All right, and now for the 2020 10B, problem number 10. It was also the 12B, problem 9. A 3/4 sector of a circle of radius 4 inches, together with its interior, can be rolled up to form the lateral surface area of a right circular cone. Let's draw something that looks like that so we can think about it. Okay, by taping together along the 2 radii shown, this one and this one are the only radii shown, what is the volume of the cone in cubic inches? Let's start accessing things we need to know. The volume of a cone is 1/3 area of the base times the height, the same as a pyramid. So we can make it 1/3 pi r squared h. Okay, so we're going to need the r and the h. How are we going to get those? All right, if you just picture what will happen if you were to stick these together. There have been several problems like this in the past in competition math. Maybe you've encountered one at some point. If you bring these together, this part that's stuck together is going to be the slant height of the cone. Okay, what about the cone here though? How is this part made? It's this connected to this, which means this 3/4 arc length is the entire circumference of our cone. Okay, so how do I get this? Well, 2 pi r is the circumference, and since r is 4, we get a circumference of 8 pi if I had the whole thing. If we don't have the whole thing, we need to multiply that by 3/4 because we only have 3/4 of the whole thing. This equals 6 pi. And that is the circumference of our cone. So we have 2 pi r equals 6 pi. R will equal 3. Now that we know this is 3, don't assume this is 5. Okay, you're going to have to do Pythagorean. So it's going to be the height squared plus 9 equals 16. Subtract and square root to get root 7. Great, we've got all the things we need. We plug in and we're done. 9/3 is 3 pi. H is root 7. It's 3 pi root 7. And that is answer choice C. All right, and now for the 2020 12B problem number 10. I'm going to solve this in two ways. The first way is the method I used on the test. The second way is probably a better way. I wish I would have thought of it during the test, but I saw it later and I think it's useful. Notice it on the AOPS solutions. In unit square ABCD, the inscribed circle omega, it looks like omega on the thing, a lowercase omega, intersects CD at M. Okay, before we progress, let's try to make sense of this. So we've got a square, and we've got A, B, C, D, and we've got a circle inscribed in this square. Technically it's circle omega, I don't really care though. It intersects CD at M, which is going to be the midpoint, because the circle always hits at the midpoint, and AM intersects omega, so if I continue and draw AM, it's going to intersect the circle at a point P that's here, different from M. What is AP, this length outside the circle? Now, it would have been great, again, if I had the other solution. Here's what I did on the test. Number one, it's a unit square, so this is 1/2. This whole side is 1/2 being to this point here. What I did is I quickly made a different one, and I made it side length 2. And I considered it in, so its side length is 2 now instead. I kind of did a little chord bash. I put 0, 0 here. I connected to the midpoint. This is 1 and 2, and this length is √5. So we could call A2, M2, calling this A2 and this M2 here, the second M value. It's equal to √5. Then I wanted to find the distance from a point to the line, from the center. The center is located at 1, 1, and I can use that with the right triangle coming to point P2. We know that this length is 1 because the radius of the circle, of the second circle, is 1. This is a similar situation. I didn't want to use the fractions that this circle and square provided. I liked the non-fractions better, so we can just divide the result by 2 to get this one. Okay, so this distance here is what we're looking for. I'm calling this x, and I know this is 1. What is the equation of this line? It's going down 2 and over 1, so it's y equals -2x plus the y-intercept of 2. Move everything to this side. 2x plus y minus 2 equals 0. To find distance from a point to a line, you're using the point x1, y1, and the line has to be written in standard form like this. If it's in that form, the distance is the absolute value of A times x1, the x1 plugged in basically, plus by1 plus c over the square root of a squared plus b squared. So with this point being 1, 1, we're going to plug it in, and we're going to get a, which is 2, times 1 is 2, plus 1 plugged in is 1, minus 2 in an absolute value over the square root of 2 squared, which is 4, plus the coefficient of y is b, squared is 1. This is going to come out to 3 minus 2 is 1 over √5. Okay, from there, we now know that this is 1 over √5, and we can solve a Pythagorean to find this distance here. So it's going to be 1 squared is equal to 1 over 5 plus x squared. The 1 over √5 squared is this. This is 1. Subtract 1/5 to get 4/5 equals x squared, and x will equal 2 over √5. Now, that's what this length is here, but over here, everything gets cut in half because it's all similar with a 2-to-1 ratio. So this distance here is now 1 over √5, because we're cutting it in half from P to right here. And we know that the distance from the center of the circle perpendicular to any chord cuts that chord in half. So I know that this piece and this piece are equal lengths, so they are both 1√5. Then if I, 1 over √5. So if I add them together, I'm going to get 2 over √5. I also know the distance of AM is going to be it was 1.5. It's going to be √5 over 2. So I've got root 5 over 2 minus 2 over root 5. That's going to give AP. So if I multiply this up to here, I'm going to get 5 minus 4 over 2 root 5 equals 1 over 2 root 5. Then I'm going to multiply by root 5 over root 5 to get root 5 over 2 times 5 is 10. That was answer choice B. All right, now we're going to go through the faster way, which is just obvious, and most of us should have seen it. Hopefully you did on the test. All you're going to use is power of a point. So in a circle, when you have a point outside and you're tangent to a circle at another point, and you also have a line that goes through the circle, let's call this X and this A and this B, then the rule is, as long as this is tangent right here, it has to be tangent, okay, then it's going to be this squared, X squared, equals the part outside the A times the whole thing, which is A plus B. Now, we're going to use that right here because this is 1/2, which is outside. And so we call this, they use the point N, I'm going to use it as well on AOPS. So AN squared is 1/4, and that has to equal AP times AM, which is root 5 over 2. Okay, all we have to do now is multiply by the reciprocal times 2 over root 5, and you get the same thing we just had, 1 over 2 root 5, which will simplify to root 5 over 10. If you use that method, great job. It's a great method.